In lesson 3.3.1, we're working with the log properties, or log laws as our textbook calls them. So I know you saw a little bit last year, but let's just review. If you have two logs with the same bases, remember log without a base is called 10. So this is log base 10 of x plus log base 10 of y. They have matching bases. If they're added together, you can rewrite them into one log and you multiply the arguments. So the two arguments get multiplied. So it's log base 10 of x times y. And then down here, so we have log base 10, so the bases match. Now when they're minused, you actually get to divide the arguments when you put them together, when you condense them. So it's always this first one, and whatever has the minus is what's going on the bottom. So the y had the minus in front of it, so that's what goes on the bottom. It just goes in order also. And then this one, I always call the flying power property. So if there's an exponent on the argument, so that's whatever we're taking the log of. So this is x to the fourth. You can fly the x, I call it the flying power property, because you can fly the exponent out front. And we actually use that a lot with solving. So I fly my 4 out front, so now it's 4 times the log of x. And it's base 10 because I don't have a base. And these properties work both directions. So I could go from multipliers, if they're multiplied, I could split them up into 2 logs being added. And if they're subtracted, I could go into division, or if they are divided now in one log form, I could split them back up into subtraction. So you can go back and forth. So this number out front, if there's a multiplier, I could actually take it back and put it back to the exponent and go back to this form. So these properties go back and forth. All right, so now let's see how we're going to use them. So just a couple examples. So this one says use the properties to write these together as a single log. So I'm going to use the properties to put this together into one log. Notice all the bases match, so I can use my properties. So I just go left to right, I usually do. So what I'm going to do is notice these two first logs are being added. So that means I can multiply my arguments. So these are going to come together into one log, log base 3 of b times x. I still have this log right here, so I'm going to write it down. I do not care if you do this all in one step. I'm just showing a couple steps so I don't confuse people. And then now I have log base 3, they match. I have added logs so I can multiply the two arguments. So I'm going to multiply. So I write log base 3, and then I multiply this by that. So it's just bxm. This guy. Same idea, but these have multipliers in front, so I actually have to use my flying power property to put them up first. So I'm going to fly all the numbers from the front up to the exponents. So that gives me log base 2 of v squared and log. So all the bases match, so I'm allowed to use my properties. So I can use those rules from above. And so now I have 2 logs minused. So again, I usually go in order, but you could jump over here, it doesn't matter. So I have 2 logs being minus, so that means I'm going to divide my arguments. So these two are going to come together to log base 2 of w to the 5 goes on top. The minus is in front of the v, so that's why I know it has to go on the bottom. So v squared's on the bottom. And then I still have this. And now I have 2 logs added, so I have to multiply the arguments when I put them together. So multiply these guys. This e has a plus sign in front of it, so it's actually just going to join the numerator. You can also do multiplication of fractions. So w to the 5, e is going to be up here, e to the 4, and v squared. So it's multiplied. Remember, e is over 1, so top times top, bottom times bottom. That's how I got this. All right, and then the other way is using log properties. We're going to expand. So now I give you the one-term log, and now you're going to pull it apart into as many logs as you can make. So I usually work with the division bar first, so I see that. So I'm going to split up the division. So I see a division bar. That means there used to be 2 logs minused. So I'm going to go this way first. So I'm going to do log base 7 of my numerator minus log base 7 of my denominator. So when there's a division bar, that means there used to be 2 logs that had the minus in front. So we're basically pulling them apart now. So now I'm going to go right here, because this one's done, there's a multiply going on right there. So that means there used to be 2 logs added. So I can actually split this back up to log base 7 of x squared plus log base 7 of y. And I still have my minus log base 7 of r. And then I have to do one more thing. For expanding, the exponent needs to fly out front. And then I'm done. So for expansion, you fly the exponent because it becomes a big size multiplier. So when you're trying to expand, you want to make it big. And when you multiply it, the multiplier is a bigger size than the exponent. That's how I always remember that. Okay, there you go. Okay. All right, and then let's do the last one. So same idea, my eyes go right to that division bar. So I'm going to split that up first. So that means, remember, log without a base. This is log base 10. I'm not going to write 10, but log base 10. And then I'm going to do the top, WH to the 4 minus log base 10 of k cubed. And then I am going to fly my 3 out front at the same time as I'm going to split this up because this is multiplied. So this is going to turn into log of w plus, because the multiply, log h to the 4 minus, I'm going to fly my 3, log k. And then I have one more. The 4 has to fly out front. Flying power property. So that gives me log base 10 of w plus 4 times log base 10 of h minus 3 times log base 10 of k.